Open your book to page 332, and let's go over the numbers. So number 1, you're looking for the symmetric equation and parametric equation of the line that passing through the point at 4, -3, 5, and is parallel to -2i plus 3j plus 4k. So this is your direction number, so right away get your fraction ready. Okay, so this is -234, so it'd be -234. So this direction number goes on the bottom. And the point, you want to go through the point, so it can be parallel to that, so we have to have these directions. So this is the direction, and over here is the location. Okay, so again, here's your direction. And on top is the location. So to go to this point, so you're going to get x minus 4, y plus 3, z minus 5. Okay. And that's it for the symmetric equation. Now to get parametric equation, you set each of these equal to t. So you get x minus 4, -2. So here's your equation. So this is your symmetric equation. So set it equal to t. And you got y plus 3 over 3 equal to t. Z minus 5 over 4 equal to t. Cross multiply, x minus 4 equal to -2t plus 4, so x equal to -2t plus 4. Cross multiply, y plus 3 equal to 3t minus 3, so y equal to 3t minus 3. Cross multiply, z minus 5 equal to 4t plus 5, so z equal to 4t plus 5. Okay, so that's your parametric equation. Let's go to number 3. Same thing, you got the point at 1, 1, 2, and it's parallel to 2i plus 3j minus k. So you can get your fraction ready. So direction is 2, 3, -1, and the point would be 1, 1, 2, so it would be x minus 1. Now we don't need a parentheses because we don't have anything else. And you got y minus 1, z minus 2. So that's your symmetric equation. And then you go ahead and get the parametric equation. You set each one equal to t. And then you go ahead and solve. Cross multiply. You add. Cross multiply. You add. Cross multiply. Then you add. And that's your parametric equation. Okay, let's go to number 5. Number 5, the point is at 2, -1, 1, and it's parallel to 2i plus j. So in this case, you're going to have, this one you only have 2, right? So you're going to get 2, 1. So you're going to get x minus 2 and y plus 1. And in this case, because there's no k, means k is constant, that means you're going to get z equal to 1. Okay, so this is going to be separate. And so that would be your equation. Now parametric equation. Okay, parametric equation, what you need to do is you need to go ahead and just go ahead and set it equal to t. So x minus 2 over 2 equal to t. And then you got y plus 1 over 1 equal to t. And again over here you're gonna just have z equal to 1. Okay, that's your constant. Okay, cross multiply. Then you add, so x equal to 2t plus 2. Cross multiply, y plus 1 equal to t minus 1, so y equal to t minus 1. Okay. And over here, you're going to, again, this one you're just going to have a z equal to 1. Okay. And that's it. Okay, let's go to number 7. Okay, number 7, you have point at 0, 0, 0, and you have and it's parallel to J. Okay, so again, this one you have no symmetric equation like the one you had before. So basically, what happened if you look at the graph, that's your x, y, z. So so this one is going to go through this point, right? Go through this point, and it's parallel to j direction. So that's the y direction. It's like this. So it's right over there. So you can see from here, your symmetric equation would be x is always equal to 0, okay, and the y, this one you don't have anything with the y because y can be any number, okay, and so you're going to get z is always equal to 0. So those are your just the two things you know, okay. Now for parametric equation, again you're going to get x equal to 0 and y equal to t, because y can be equal to any number, right? See over here? So y can be any number, and that's the variable t. And you're going to get z equal to 0. So that's would be your parametric equation. Okay, let's go to number 9. Okay, number 9, you have to do additional steps. So you got P1 is a 1, 2, 3, and P2 is negative 2, 4, 0. So this one you don't have any vector, so you need to do one step. So you need to get the vector P1, P2. So you subtract, so you're going to get negative 3i plus 2j minus 3k. So from here, it becomes like previous problem. Okay, so again, this is your direction numbers would be negative 3, 2, negative 3, and use this one, you're going to get x minus 1, y minus 2, z minus 3. Okay, so that would be your symmetric equation. And for parametric equation, okay, this one you don't, it does not ask for parametric equation, so you're done. Okay, but if they ask you for parametric equation, just set equal to t and just solve. Okay. Okay, number 11, you got P1 is at 1, 0, 2, and P2 at 0, 2, 1. So again, first you get your vector P1, P2. So you have to subtract, so it would be negative I plus 2j minus k. Right? So you can just subtract. So that's your directions. So once you get your direction, you put your number down here, so negative 1, 2, negative 1, right? And then point, you're going to get x minus 1, y minus 0, z minus 2. Okay, and that would be your symmetric equation. Okay, number 13, your P1 is 2, 5, 4. P2 is at 2, 4, 3. So you can get your P1, P2, get your direction. So when you subtract, this cancel out. This subtract, you get minus j. This minus, you get minus k. Okay, so in this case, notice that x is always equal to 2. So you're going to get x equal to 2 because by itself, because there's no I, right? That means the x is constant. And from here, you're going to get the negative 1, negative 1. Okay. And so from here, you're going to get, now you have to watch now. This is for j, right? So this is, you have to use the y, right? So keep track of your x, y, z. So y minus 5 and z minus 4. Okay. So that would be your symmetric equation. Okay, let's go to number 15. Number 15, your P1 is negative 1, 3, 4. P2 is 3, 3, 4. So P1, P2 equal to, when you subtract, you're going to get 4i. This one gets 0, 0. So that's all you have. Okay. So now, in this case, your equation would be, notice this is constant, so this one you're going to just have, you're going to have the y equal to 3 and z equal to 4. Okay. And this one you don't really have a symmetric equation, but if you're going to write, I guess you can write the x equal to t, because x is going to be any number. Okay. So this is more like a parametric equation. Okay. But this is, so when you do it this way, that's fine. Okay. So you can write it this way. Okay, let's go to number 17. Okay, so you have two equations. You got x minus y minus 2z plus 1 equal to 0. And you got x minus 3y minus 3z plus 7 equal to 0. And so this one you have to do everything. So you got to do additional steps. So first you have to do is get 2 points. Okay, you have to get 2 points on so you can form a line. So basically, again, you have the intersection. So you need to look for this point and this point. Basically, you're looking for P1 and P2. Okay, and so what you want to do is, again, you want to you want to choose the highest coefficient and set it equal to 0, and then you can get points. Yeah, that way you don't. So that's going to let. So notice the y and the z has the highest coefficient, right? So I'm going to let y equal to 0. Okay, so you're going to get x minus 2z plus 1 equal to 0. Okay, and you got x minus 3z plus 7 equal to 0. And from here, I'm going to multiply this by -1. So I got negative x plus 3z minus 7 equal to 0. Then I'm going to put this over here. So I got x minus 2z plus 1 equal to 0. So you solve, you're going to get z minus 6 equal to 0. So z equal to 6. Okay, and I'm going to come over here, look for x. So I get x minus 2 times 6 plus 1 equal to 0. So again, basically I'm just looking for points on both of the planes, right? Okay. So you got x minus 12 plus 1 equal to 0, x minus 11 equal to 0. So x equal to 11. Okay, so from this you get 11, 0, and 6. Okay, so now you have to let, I'm going to let, so here's 1 point, so that's your P1. So now I'm going to let z equal to 0. So let z equal to 0. So from here, okay, go back to the equation. So I get x minus y plus 1 equal to 0. From here, I get x minus 3y plus 7 equal to 0. Okay. And then again, I'm going to multiply this by -1. I'm trying to eliminate the x. So put this over here. So I get x minus y plus 1 equal to 0. So this I get 2y plus minus 6 equal to 0. So 2y equal to 6. So y equal to 3. Okay. So now substitute back in here. So I get x minus 3 plus 1 equal to 0. So I get x minus 2 equal to 0. So x equal to 2. So from here, my P2 is going to be 2, 3, and 0. Okay. So once I find these 2 points, I can go. It becomes like a number 9 through 15. Okay. So next I'm going to do is, so this is number 17. So P1, P2 will equal to, you have to subtract, so it will be minus 9i plus 3 j minus 6k. Okay. Then after that, so actually this one you can actually divide. Okay, you can shorten your, notice you can divide it by -3 or you can divide by 3. Okay, either way it doesn't matter. So basically you can shorten your vector or your line. So I'm going to divide this by 3, so I get -3i plus j minus 2k. Okay, and so from here I can get my equation ready. So -3, 1, -2, and I'm going to use P1. So I get x minus 11, y, z minus 6, and that would be my equation. And number 19, you just do the same thing. Okay, number 19 is kind of lengthy, so do exactly the same steps. Okay. So again, for this one, it's a little bit lengthy. So you have to set one of the variable. It doesn't matter, but this one I use set the y equal to 0 and z equal to 0. So set the equal to 0, and you solve for the other two variable, and that's your P1. And then let z equal to 0, okay? And then you solve, and then you get the x and the y, so it's your P2. And once you find P1, P2, it becomes the previous problem. Okay?